inter-VLAN routing. Now, whenever we talk about inter-VLAN routing, it is moreover in between the two switches we want to pass a traffic for multiple VLANs. What we use is the trunk, right? This part, correct? What we use? Trunk. What is the basic rule of trunk? Do the tagging of VLANs, right? Yes or no?
Yes, sir.
So if a traffic is being received over here in VLAN 10, and let's assume there is another machine connected over here, which is part of other machine PC4, which is part of VLAN 10. Any traffic received from Windows 2, whenever it will be traversing from switch 1 to switch 2 on the trunk link, it will have a details of which VLAN? VLAN 10, correct? Yes or no?
Yes.
Okay.
Yes, sir.
Doubt in the CAM table operation, explain L2 forwarding and L3 forwarding. Yesterday, Murthy, yesterday we already covered that, right? What is L2 forwarding?
MAC address.
And what is L3 forwarding?
IP address.
So whenever you are forwarding on the basis of IP address, that is called as L3 forwarding.
Oh, so only that is the difference, or any?
No other difference. So, okay. So whenever we talk about L2 forwarding, only CAM table will be taken. What is another name of CAM table? MAC address table.
MAC address
right?
table. Yeah.
Let's say I am interested to send a traffic from I'll cover this doubt first, okay, before we start. Let's say this is a machine connected over here. 10.1.1.1 is its IP address, correct?
Yeah.
And here I have configured IP address to be 10.1.1.2/24. Now I want to send some data from 10.1.1.1 to 10.1.1.2, correct? What is going to be my source IP? 10.1.1.1. What is going to be my destination IP?
10.1.1.2.
10.1.1.2. Are they part of same subnet? This is /24. This is /24. So are they, if they are part of same subnet, what is the next step that this device will do? If you are having a same subnet, what it will see? It will try to find out again. This is your network layer, right?
Yeah.
From network layer, you will be moving to which layer? Data link. Data link layer. Now, do you agree that if source IP and destination IP are of same subnet, this machine or this Windows machine over here, or any machine which understands all these things, will refer the ARP table to find out the MAC address?
Yes, sir.
Okay, Moti, is it clear for you? ARP works on same layer, same subnet or different subnet?
Same subnet.
Same subnet.
Same subnet, right? So 10.1.1.1 and 10.1.1.2, are they same subnet or different subnet? Both are /24. You guys need to answer me. I'm asking you a CCNA question.
Same subnet, sir.
Same subnet.
Same subnet. If it is going to be same subnet, can it refer ARP table?
Yes, sir.
No.
For same subnet, it is going to refer the ARP table to find out the destination MAC. That is the biggest difference how exactly ARP works. What will be source MAC here? Tell me. Let's assume this is A and this is G. What is going to be the source MAC? It will refer ARP table. What is the purpose of referring the ARP table?
MAC address.
To find out the MAC address.
MAC address.
If ARP table don't have an entry for 10.1.1.2, what this Windows machine will do? It will generate the ARP broadcast, correct?
Yes.
And that ARP broadcast will be sent to switch 1. Yes.
Yes, sir. Yes.
Which one will receive that R broadcast in which VLAN?
10.
10. It will do the flooding of that specific broadcast towards all the interfaces on VLAN 10, right?
Yes, yes.
Is this trunk part of VLAN 10?
Yes.
So by that means this flooding will also reach to switch 2.
Yes.
Switch 2 will also do the same thing. It will forward it towards PC4 and all the interfaces where VLAN 10 is configured.
Yes, sir.
So by that means PC4 will receive the R broadcast.
Yes.
And if it is going to receive the R broadcast, what it will do? It will create a reply. Yes or no?
Yes, yes.
Yes.
Murthy, you clear now?
Yeah, Sumit, clear.
Okay. Now what this PC4 will do? It will create ARP reply and send it back to Windows 2 machine. Now my ARP table on Windows 2 machine will have the entry that if it wants to reach 10.1.1.2, it needs to go to MAC address G. Correct?
Yeah.
Yes, sir.
Now, what is going to be my source MAC whenever Windows machine creates the packet, creates the frame? A, which is a local MAC address.
Yes, sir.
And what is going to be the MAC address of, what is the destination MAC address?
G, sir.
G, correct?
Yes, sir.
Now, this frame will be received on which device? Switch one? What switch one will do? It will check out the destination MAC. Does G MAC address belongs to switch? This switch one?
No.
No. What it will do? It will check out the MAC address table to find out how to forward the data towards G. Correct?
Yeah.
And from that approach, only MAC address will be used whenever you will be doing the L2 forwarding.
Okay.
Understood how exactly L2 forwarding will be happening in this case, and what is the purpose of CAM table or alternatively MAC address table?
Yeah, Sumit.
Yeah.
Now, if we talk about L3, what will happen? It needs to do the routing. When I say L3, it means I am trying to send a data bit from 10.1.1.1 to this machine over here whose IP address is 20.1.1.1. Correct?
Yeah.
Deep Narayan, can you be on mute? There is a lot of background noise on your side. Thank you. Now, whenever we have a different subnets, what switch will do? What machine will do? It will send a data towards, or it will send a packet towards L3 gateway. Switch one is my L3 gateway.
Yeah.
And it will refer the routing table first to find out if it is directly connected to it or not. Yes or no?
Yes.
Yes.
If it is going to refer the routing table, this is what we have already seen yesterday. Routing table will be first. It will find out it is present as connected.
Okay.
And if it is connected, it will refer the ARP table.
Okay. ARP table, yeah.
From ARP table, it will find out the MAC address. And from MAC address, then it will refer the MAC address table to find out the exit interface. This is the difference between L2 operation and L3 forwarding operation from CAM's perspective.
Okay.
Got all the clarity now?
Yeah, Sumit. Thank you very much.
Should we move ahead?
Yes, please.
Thank you. Okay, moving back to the topic. So we saw that any traffic that is going to originate from any Windows machine landing on a switch, and whenever we want to send it across or towards another switch, ideally we use this trunk. What trunk does? Tagging of data. Correct?
Yes.
Tagging of VLANs, not
VLAN.
data. Yeah. Now, this trunk can be defined in two different ways. When I say two different ways, it means from a perspective of how exactly you will define the trunk. There are two options through which you can achieve it. Option number one is going to be 802.1q, which is open standard. This is IEEE standard 802.1q. Okay, whereas this is IEEE. Whereas another option is Cisco proprietary, which is known as ISL. I believe the full form of ISL is inter-switch link. Understood? What is the difference? Like, what are the two types in trunk?
Yeah, got it.
Okay. Everyone clear about this?
Yes, sir.
Yes,
Okay.
sir.
Now let's move further. First of all, this is outdated. Majorly in today's era, no one uses ISL. There would be exceptional cases, but in my 10 years of career, I haven't seen anyone using ISL. We'll cover a bit part of ISL. Major part, what you need to understand is 802.1q. Okay. So first, what I will do, I will open up the 802.1q header to understand what are the things in it. And if I open it, this is how it looks like. Let me clean this up and we will write down rest of the things step by step. Where are the things? Yeah, this is the diagram. Okay. Hope diagram is visible.
Yes.
Okay. Now, if you see the details, 802.1q ideally is of 4 bytes. How much? 4 bytes.
4 bytes.
Okay, let me bring out another diagram. Something bigger. No, not this one. Yeah. Is this good now? Is this visible?
Yes, sir.
Okay. 802.1q ideally is of how much bytes? 4 bytes. Okay. Now, if I say it is 4 bytes, it means how many bits? 1 byte is equal to, don't tell me, come on, this is CCNS first chapter.
8 bits, sir. 8 bits.
32.
So total will be
32.
32 bits.
32.
Now, if you see that how exactly this 32 bits are divided, they are divided like this. And what are the values in it? What is TPID? TPID is nothing but tag protocol identifier. This is the first component what you are learning. What? Tag component identifier. Now, what is the value or what is the importance of this? Do you remember we have token ring? If I show you any device and if I just open it, show VLAN. Do you see we have FDDI, we have token ring, FDDI net, TR net, correct? Different types. Same way we have Ethernet. You agree on this? ENET. ENET means Ethernet, correct? Now, if we talk about this specific one, this tag protocol identifier it will basically help you to identify at layer 2, this specific type of frame is either token ring or Ethernet or something else. And all the technology what we are learning today or all the technology what we are working today is on Ethernet, right? Yes or no?
Yes.
Yeah. So out of that, this, if you see the first one, typically 0x8100, this is nothing but your Ethernet or 802.1q identifier. This will basically show you that this is nothing but a Ethernet frame. And if you want to see this, maybe in Wireshark, we will be able to see it. Yesterday, we had opened, we had downloaded Wireshark for 802.1q, I believe. Let me try to find out that. If not, we will open another one. Okay, it is not there. Hold on. Let's just 802.1q packet capture. Yeah, this one, ICMP across. If you open up any this 822.1q, do you see it anywhere? No, it is not there. It is not added in this. Let me see some different packet. Okay, this one. Do you see this? 0x. Hold on. What was the value we saw? 0x8100. Let's validate it here. This is different. This is not that value what we are talking about, but ideally it is not getting captured in the packet, but this is where it will ideally show you that what kind of frame this is, whether it is token ring or it is Ethernet or it is something different. This is the value of your TPID, which holds 16 bits. Clear till now?
Yes.
Now, what is priority? You remember we need QoS. You agree on these terms, we need QoS, quality of service. Why? To prioritize the packets. Everyone is aware about what is QoS. You don't need to go in depth, just one liner. What is the purpose of having QoS?
Bandwidth shaping.
Yeah, you can say that. What else? Or in general terms, if I ask you in general terms, what is the use of QoS? To give priority to some important traffic, correct?
Yes, sir.
Now think it. Either you will be setting QoS at your network layer, right? If we talk about network layer, or if we even open any kind of packet, this same packet, and if I open the IPv4, do you see this value DSCP CS0? This is where you ideally set the QoS at layer 3. But you also need to think about setting up the QoS at layer 2, because if any switch is doing the forwarding at layer 2, it is never going to open this IPv4 packet, right? It will be only checking the details of source MAC, destination MAC, and this specific encapsulation or trunking part. That's why we have a dedicated bits, which are like 3 bits, I would say, which is for your L2 QoS. Understood? Understood or not?
Yes, sir.
Okay. CFI. If I go in detail about CFI will basically, there is not either this value is set to 0 or this value is set to 1. This is an additional option, or this is an additional value where it shows us that this is the Ethernet frame. So if this value is set to 1, then I believe it is considered as an Ethernet frame, and if this value is set to 0, then it is considered it is non-Ethernet frame. This is an additional tag of 1 bit what they have given. And last but not the least, this is where your VLAN ID details are carried out. This is where you are going to talk about the details that VLAN ID will be present. Clear till now? This is where your tagging will be done in this VLAN ID. That's why the number is 024095 here. Any kind of doubts till now?
No.
Okay. Now, if you are going to talk about, this is moreover a single tagging. Single tagging, what do I mean by that? It gets tagged in between your destination source address and type and length and all those things, but nothing is added at the end of this Ethernet frame. That's why it is called as single tagging, which is different as compared to ISL. ISL do 2 types of tagging, one tagging at a header and one tagging at a trailer. That's why it is also called as single tagging. Clear on this? No one is going to ask you anything exceptional. Worst case, worst details, they will go into this header, and they will ask you details, what is TPID or what is priority or what is CFI. But no one is going to ask you anything except this. Or another question from interviews approach, someone was asking me, I believe yesterday, and they will ask you what is the difference between 822.1q and ISL. That's it. Clear till now?
Yes, sir.
Yeah.
If not clear, feel free to tell me. I will explain it again. Okay. Now we'll do the lab for this one. What do you call 822.1q, and then we will move into the ISL part. If I want to set up a trunk. How will I set up the trunk? Let me first change yesterday I had already done that part. I will remove it. Default interface Ethernet 0x2. I have removed the configs. Let me do it from both switches. Default interface Ethernet 0x2. Now I don't have any configurations present on Ethernet 0x2, which is ideally the trunk port between the two switches. Ideally, we expect them to have a trunk port. So this specific configuration is going to lie and sit under the interface, because trunk is always going to be configured under individual interface. Either it will be access or it will be trunk. There is nothing global that would be happening over here. Okay. Now, these are the important commands in this switch port mode trunk. But if you see here, if you put this command, it is giving you a problem that there is an encapsulation mode, which is auto, which is by default set on Cisco switches. And if you want to have a dedicated mode, first you need to define whether you want to run ISL or you want to run which type of trunk you want to basically run. So if to do that, what I have to do, switch port trunk encapsulation. And do you see one is .1Q, one is ISL, and one is negotiate. You understood what is .1Q already, right? What is negotiate? Negotiate means whatever is set on one side, it will be automatically negotiated on another side. So if I am setting one side to be .1Q and on other side, I will say if it is negotiate, then by default, it will negotiate with 802.1Q. That is an option what Cisco have given. Clear till now?
So, but in most of the production, they will use .1Q only, right?
Yes. Reason being, because if we talk about ISL, the total header length of ISL is of 30 bytes. How much?
30 bytes.
30 bytes. So if I go back to the same diagram, what we just saw, 802.1Q, not packet capture. I want to see the header. Images. I guess I opened this one. Right now, if you see, this is a total combination 6 plus 6, 12 plus 4, 16, right? Plus 2, how much it is? Or in general, if we check out the Ethernet frame length, ideally it is 14 bytes something. Yeah, exactly. Do you see this? Ethernet frame length. Let's assume the data what you have received from your upstream is of 1500 bytes, correct? So this part is 1500, which you have received from network layer. Plus all this, if you include all this, it is going to be 1518. So you need to understand this important factor, that because 822.1Q is only of 4 bytes, that's why the length over here is how much? 1518. And maximum, this is value is what we ideally are sending on the remote side. 6 plus 6, 12 plus 4, 16 plus this may be present, may not be present. Hold on, let's calculate it again. 6 plus 6, 12 plus 4, how much it is? 12 plus 4, 16 plus 2, 18. So this 1518 plus this tag 22. Is of 4 bytes, 1522. Now, whenever something like this is going to happen, this data, this value is going to get reduced. And because this tag is an extra head over or extra, overhead on the device, 4 bytes are still fine. But if we talk about ISL, it is of 30 bytes, which consumes a lot of actual data transmission. That's why ISL is not that famous. Everyone clear why ISL is not being used? Majorly because of extra overhead what it carries. Any doubts?
Okay, sir.
And I'm going to say switch port trunk encapsulation .1Q. This is going to be my first command. You can write it down. Second command, what I'm going to put is switch port mode trunk. Okay. Now, if I do show interface trunk, it will show you the output of how exactly trunk looks like. Just give me one moment. Yeah, so if we talk about it, because we haven't configured, we have manually said that we want to use 822.1q. That is the reason it is showing you. Encapsulation type is 822.1q. Status is trunking because we are trunking the part. Native VLAN, which we will cover later on today. What are the VLANs that I have allowed? These are the number of VLANs what I have allowed on this interface. Now, if you see, these are the total number of VLANs what I have allowed, but because I have only created VLAN 1 is by default and I have created 10, 20 and 30. That's why it is saying that at this moment, these are the active VLANs. If I specifically remove one VLAN that I don't want to permit some different VLAN or some, let's say VLAN 100. So Ethernet 0/2, switch port trunk and switch port trunk allowed VLAN remove 100. Let's assume I have removed VLAN 100 from this. You see the difference now. What I'm saying, I am not permitting VLAN 100 from here. Do you see that?
Yes.
Okay, so you have to understand this. Majorly in your production setups, no one is going to say, I'm going to allow all the VLANs. They will be very specific that if they want to allow VLAN 10, 20, 30, 40, maybe 100, 200, 300, they will only allow these many VLANs. They will not allow rest of the things. First, this is a production example. Now let's assume that you got a task that you need to remove VLAN 200 from this specific whole setup. We will do it for maybe VLAN 20, for example. Now the command what you have to use in that case is switch port trunk allowed VLAN. If you just put, if you don't ideally use remove, it will not remove a specific VLAN. Let's say if I'm going to remove 20, it means I am not permitting VLAN 20 on that interface. And if you see now, 20 has been removed. On the above side, VLAN 20 was permitted. Is it clear with respect to trunk? How can you configure the trunk?
Sir, if we do not want to mention the VLAN for remove or allow, then what will happen in that condition?
You said you don't want to remove the, you don't want to mention the VLAN, what VLAN you want to remove.
Yes, yes.
Switch port trunk allowed VLAN. If you are using something like this.
Yes, sir.
But there is no command which you can execute. You have to add something. Let's say you by default, you wanted to remove it, but you said that you want to, by default, let's assume you executed this command, switch port trunk allowed VLAN 20. What do you mean by this?
If we put it remove 100, okay.
Okay.
And we do not want to mention for allow 100, only would put it trunk allowed VLAN.
Okay, so there are different things. First of all, the moment you say switch port mode trunk, that port becomes trunk. Okay, now you have to explicitly tell which VLAN should be removed or which VLAN should be added. By default, as of now, if I show you, let me remove this command. Okay, or maybe do show interface trunk. Do show interface trunk. Do you see all the VLANs are permitted now?
Yes.
VLAN allowed on trunk. What do you see? 124094. Let's say, let me create one more VLAN randomly, 100. And if you execute the command one more time. Okay, I don't have any port, I believe in that. Let me try this. Show VLAN first. VLAN is created. Show interface trunk. Okay, what do you see now? 100 is active.
Yes, sir.
The moment you create any new VLAN, it will be automatically pushed that it is allowed on trunk. Okay. Now, if you want to be very specific that you don't want VLAN you don't want another VLANs to be permitted except 10, 20, 30, then you have to say switch port mode, switch port trunk allowed VLAN 10, 20, 30. And it is only going to permit 10, 20, 30 and rest all will be denied.
Yes, sir. Got it.
Understood? Is that clarifies your doubt?
Yes, sir. Clear.
Okay, now do you see what it says? VLAN allowed on trunk only 10,
10,
20 and 30.
30.
So it totally depends. Now you have got a job that you should be removing VLAN 30. It is of no use. Now, if that is the case, you have to say switch port trunk allowed VLAN remove 30. Okay.
Yeah.
Why I'm specifically telling all these things? People have done blunders over here. That's why I'm saying. That's why I'm telling you all these things. These are the very smaller things, but people do mistakes over here.
So
Okay.
if you want to add the VLAN 40, just switch port trunk allowed VLAN add 40, right?
Add 40. Exactly. Yes. Add 40. If you don't say add 40, it will only permit 40 in that.
Yes, sir.
Okay. So now, if I show you do show interface trunk, what are the VLANs we have permitted? 10 and 20, right? Now, if I say switch port trunk allowed VLAN 40, I forgot to add the keyword ADD here. Okay. And you see what is the blunder we have done.
In that case, we have mentioned VLAN allowed only trunk on 10 and 20, but we have not mentioned about 40. That's why we got, na, sir? Yeah.
So first of all, earlier it was 10 and 20, right? Then what you said, the new command, what I'm going to say, switch port trunk allowed VLAN 40. So whenever you want to add something, you have to write down that you're interested to add that VLAN. Understood?
Yes, sir.
Yeah.
Instead of switch port trunk allowed VLAN 40, we have to mention switch port trunk add 40, I think.
Switch port trunk allowed VLAN add 40.
Yes,
if
sir.
I do that, now you see 10, 20 as well as 40 has been added.
Then we will get the VLAN allowed on trunk 10, 20 and 40.
Exactly. So you have to add or you have to remove, and many people do mistakes over here. Okay. That's why I have been very specific about this.
Yes,
clear?
yes. Very clear, sir.
Now I have to do the same thing on other side, but before that, maybe I can check out what exactly is happening. Yeah. You see, by default, if you see, I haven't added any kind of configurations here. Interface Ethernet 0x2. Do you see anything? Any kind of trunk? No, right? So whenever you have a default or any kind of no configurations present, by default, your switch is in auto negotiation mode. Whatever is going to be sent by other side, I will negotiate with that. That concept is called as dynamic trunking protocol. What do you call it?
Dynamic
trunking protocol. Dynamic means dynamically trunking protocol will negotiate with each other. So on one side, you have explicitly said that I want to run 802.1q, correct? On switch one, you have already said that. You agree on that? But
so
on switch,
what did you say? Dynamic trunking
protocol, DTP.
Yes, sir.
So by default, DTP is running on all the Cisco switches. Understood?
Yes, sir.
And do you see it is saying that encapsulation method, what it is using is 802.1q. But what is the difference over here? It is written as only 802.1q, whereas here it is written as n-802.1q. What do you mean by n? N means I have negotiated whatever the remote guy has sent to me. Clear? Clear or not?
Yes, sir.
This is my switch 1. This is my switch 2. Okay. By default, there is a concept called DTP, dynamic trunking protocol. What it does, it basically tries to negotiate the trunk between two switches.
automatically.
Now, what we have done on this switch, I have said that I want to run 802.1q, correct?
Yes,
On
sir.
switch 1, I did that, but on switch 2, I haven't done any kind of configurations, right? And here is an important factor. Dynamic trunking protocol is helping this switch to automatically negotiate with switch 1. What it is saying, that switch 1 is running 802.1q, I will also be running 802.1q. And that's why it is saying N, because it is negotiated. Negotiated means, what do you mean by negotiated? Whatever another device is running, I will accept that and I will run that specific trunking protocol. You understood this?
Yes, sir.
Now
Yes, sir.
let's try something. I will add one more VLAN over here. Switch port trunk allowed VLAN, add 100. Let's try this. This is good. Let's validate if something different has happened over here. Nothing, no difference. Do you see why? What are the VLANs I have configured over here? 10 and 20, right? So it is only going to allow 10 and 20. If I have a new VLAN created, maybe 300. Okay, VLAN 300 is created. It automatically added VLAN 300 in it. Clear?
Yes, sir.
Any kind of doubts, feel free to ask. I'm giving 1 minute to revise, to think, or any possibilities.
Sir, why it is added 300 when we create the VLAN 300?
Randomly, just to show that these VLANs, okay, whatever you create locally, those only will be added to trunk. So DTP don't exchange the information about VLANs which are allowed on your another switch. DTP will only help you to negotiate. It will not help you to exchange the VLAN data. That what VLANs are permitted on switch 1 and the VLANs permitted on switch 2, both could be totally different. Understood? Who asked me this question?
Sir, me.
Sanjay. Yeah,
Yes.
Sanjay. Understood, Sanjay? What is the difference? Why I added VLAN 300? Randomly, I took one example just to show that because we have allowed everything over here, it will permit those VLANs.
So little bit of confusion.
Tell me, what is your confusion?
Sir, actually, I couldn't understand about you created the VLAN 300. So, what is the procedure? What protocol backend working on the VLAN 300s? It automatically added in VLAN allowed state 300.
Sorry, I was talking on mute. So your question is that if I just create a VLAN 300, how exactly it was added to trunk? That is your question?
Yes.
Okay, understand. You need to understand this.
And sir, why? Which protocol is used?
There is no, this is an internal mechanism or internal algorithms which are running on the devices. There are no dedicated protocols for that. Okay, let me try to explain. VLAN, the moment you are creating a VLAN, this VLAN algorithm will be informing to the trunk algorithm that there is a new VLAN allowed. There is a new VLAN created on this device. Okay, what trunk will do? Trunk will say that wherever I have VLAN 300 permitted, I will allow the VLANs over that. If I have some interface where I don't have VLAN 300 permitted, I will not do that. So VLAN, the moment VLAN is created, the algorithm behind VLAN will be informing it to the trunk, and trunk will take care of rest of the things. And if you want to test that, let's take another example. First, I will deny some VLAN. Okay, I will say, let's assume VLAN 400. Switch port trunk allowed VLAN remove 400. Okay, following me?
Yes.
What it says, VLANs which are allowed on trunk 1 to 300 and 401 to 4094. Correct? That means 400 is not allowed.
G. Right.
Now I don't have VLAN 400 created over here. Okay, let's check out if VLAN 400 is created. Do you see VLAN 400 created?
No.
No,
Means
right?
first of all, we have to create VLAN, then add VLAN,
Or
then
remove. Yeah, exactly. So
or allow or remove.
yes, exactly. Now let me what I need to do. I have to create the VLAN. Correct? I have done
Correct,
it.
sir.
I created the VLAN. Do you see VLAN 400 is created?
Yeah, sir.
So what would have happened? That the algo behind VLAN would have informed it to trunk saying that VLAN 400 is created. What trunk did? It checked out that wherever I have a trunk interface, whether I have VLAN 400 allowed on it or not. If not allowed, I will not permit it to pass through, or I will not add it to the list of allowed VLANs.
VLAN. Yes, sir.
Now, if I just execute the command again, show interface trunk, you see VLAN 400 is not permitted. Clear?
Clear, sir. Clear.
Who asked me this question? Sanjay.
Yes, sir. Clear, sir.
Should we move ahead? So to revise the commands, what you have to done? Switch port trunk encapsulation .1Q and switch port mode
Access.
trunk, not access, sir. Access is not here.
Trunk.
Sir,
Sorry.
sir, actually, when we create one VLAN, it will be automatically tell to trunk port. It is created and add the trunk table.
Yes.
See, this VLAN is created. It information in trunk port table and the VLAN table.
Sorry, there is a background noise. I could not understand. What is the last line you said?
Sir, both in the information in both table, na VLAN and trunk table.
Yes, it will be there.
But sir, one thing I am only one thing confusion. How it will to inform the trunk? Any protocol behind?
There is no dedicated known protocol for this. This is moreover an internal algorithm which is mapped between different protocols which are working in a collaboration. There is no dedicated protocol defined for this.
Okay, thank you.
Very simple example. Okay, you have already learned OSPF, or you know OSPF, right? Bit OSPF.
Yes. Yes, I know OSPF.
You know R1, R2. Okay.
Yes.
Let me take an example. This is Ethernet 0 by 0 and 0 by 0. Correct? Now
Right.
you need to think about it. Let's say OSPF neighborship has been up, all good. Your hello timers are 10 seconds, dead timers are 40 seconds. Standard timers, whatever Cisco says. We haven't modified them. Okay. Let's assume this link goes down. Okay.
Right.
Will the router 1 and router 2 wait for the dead interval of 40 seconds for the neighbor to go down, or will it automatically shut down the neighbor whenever your physical interface has gone down?
Sir, automatically it will be go down.
Sir, wait for 40 seconds, sir.
Sorry?
Sir, wait for 40 seconds.
No, it is not going to wait for 40 seconds in this
It will
case.
automatically
After 40
go down.
seconds, he will send again the message.
Okay, so you need to understand this. Who said that? Akshay or someone else? I'll come to that example also. I'll tell you how. What will happen in this case is, because this Ethernet 0 by 0 is directly connected to you, right? Now, the moment you are defining a network, you already know that this interface is part of OSPF, and it is that OSPF is constantly tracking the interface status. And if my interface status is going to go down, OSPF will understand that it has gone down, and I have to remove the OSP of neighbor running over it.
Sir, it will wait when the network
It
behind
will-
the R2.
It will wait. No, network behind R2 is not going to be there. The neighborship will be on directly connected one. It will wait in what scenario? Let's assume this is
लेकिन सर
R1.
मैं ये कहना चाहता हूँ कि अगर ये R2 के पास नेटवर्क होता है अगर कोई और उसको OSPF में हम कॉन्फ़िगरेशन किए रहते तो ये शायद वेट करता
नहीं होगा, वो केस में भी नहीं होगा. It will not be that it will not be that case. Why? Let's assume there is a LAN network here, 20.1.1.0/24. Okay. The moment this interface goes down, and if you have been advertising it into OSPF, the moment it is going down, the interface is going down, it will be removed from OSPF. It is directly connected to you, right? Yes or no?
So it means broadcast network will be wait for 40 seconds, sir.
No, I'll give you the example where it will wait for 40 seconds. But have you understood this? This was just an example I was picking. Have you understood the logic behind it? How exactly VLAN are going to inform it to the trunk and what actions trunk will take?
Yes, I understood.
Okay, the last one. With respect to that, it will wait for 40 seconds in what scenario? This is your L2 switch. Okay, here out this, and you have formed a neighborship between R1 and R2. This is L2 switch. Let's assume this link went down. What went down? Link went down. This one. Do you think R1 will wait for 40 seconds or not?
After 40 seconds, he will break the neighborship.
Why R1 will wait for 40 seconds?
Because sir, its interface is up. R1 interface is up.
Yes, R1's interface is up. R1 don't know what has happened one device beyond of it. R1 don't know that there is a link which has gone down between switch one, L2 switch and R2 device.
सर अगेन सेम डाउट हो रहा है मुझे. सर अगर मान लो कि R2 के बिहाइंड में ये आपका लैन सेगमेंट्स है और R2 पे कोई फिजिकल कनेक्टिविटी डाउन होता है. सर फर्स्ट सिनेरियो पे चलिए आप प्लीज, टोपोलॉजी फर्स्ट पे.
This one.
जी, तो यहाँ पे अगर मान लीजिए कि अभी नेटवर्क हमारा डाउन होता है तो R1 जो होगा वो तो सर 40 सेकंड के लिए वेट करेगा ना इस नेटवर्क के लिए.
नहीं वेट करेगा ना, क्योंकि R2 क्या करेगा, जो मूवमेंट पे ये डाउन चला गया R1 R2 R1 को इन्फॉर्म कर देगा ये डाउन गया है. That's how the faster convergence is achieved, right? हर बार अगर 40 seconds के लिए वेट करना है, then you are not achieving the faster convergence.
इसका मतलब सर अगर यहाँ L3 स्विच होगा तो भी नहीं करेगा ये.
Doesn't matter whether it is L3 switch. If something which is directly connected to you, if it is going to go down, it is going R2 will inform it to the neighbor.
नहीं सर, मैं इस सिनेरियो पे सेकंड सिनेरियो पे मैं आ गया. यहाँ पे अगर
let's assume this is L3.
यस, तो फिर से सिनेरियो वही होगा कि मतलब ये वेट नहीं करेगा 40 सेकंड के लिए.
Okay, hold on. You need to understand both scenarios are different. This one is different. Here R1 is directly connected to R2. Correct? You agree?
Yes.
Here R1 is not directly connected to R2. There is an in-between device.
Yes.
It doesn't matter if it is L3 or L2. If it is, acha, tell me, how does R1 will come to know there is a link which has gone down between this switch and R2 device? Is there any way?
Yes, by the switch.
Switch never will do something like that. This is a L2 switch, or even if this is a L3 switch, if this is L3 switch, then you can't form a neighborship between R1 and R2 on whatever is requirement. You can absolutely form. I'm not denying it. Very simple example. Let me give you. Let's say this is VLAN 10. Okay. You have put it in access and you have put it in access in VLAN 10. Clear till now?
Yes.
Now you have configured IP address here to be 10.1.1.1 and here you have configured IP address to be 10.1.1.2. Okay.
Right.
And even if this is a L3 switch, doesn't matter. Even if you have configured SVI over here for VLAN 10, will R1 form neighborship with R2?
Yes, sir.
Yes.
Yes.
Now, if this link is going to go down, why L3 switch will inform it to R1? Why this switch? You are forming the neighborship between R1 and R2, right? You are getting confused between the two.
सर ये वेट किस सिनेरियो में करेंगे सर और सिनेरियो बताना आप एक बार
वही मैं बता रहा हूँ. Okay, let me tell you in what scenario ideally it will wait. First of all, you need to understand R1 switch R2. Okay, clear with topology? Is everyone clear with topology?
Yes.
You have formed a pairing between R1 and R2. Clear? This pairing is OSPF pairing. And let's say this link went down. R1 will wait for 40 seconds because R1 don't know that a link has gone down between switch 2 and layer 2 switch and R2. That's why R1 have to wait for 40 seconds to find out that the remote peer has gone down. Is it clear?
Yes, sir.
ओके सर
Samjha? I mean, R1 is not going to know that the link has gone down between this. Let me bring another example. R1, this is my first L2 switch, and this is my second L2 switch. Can I form a neighborship between R1 and R2 in this topology?
यस सर
You can form the neighborship, right? These are L2 switches. L2 switches are going to work at which layer? Data link layer. They'll not be bothered about anything else. Now tell me, if this link is going to go down, will R1 come to know there is a link which has gone down between L2 switch, switch 1 and switch 2?
नो सर
Will it wait for 40 seconds?
Yes, sir.
Same way, will R2 come to know that there is a link which has gone down between L2 switch, switch 1 and switch 2?
it means when router directly connected then no wait for 40 seconds.
Yes. If it is directly connected, then only they will bring down the neighborship quickly.
ओके सर
Understood?
यस सर
Yes, sir. Understood.
Okay. Should we move ahead to ISL part now?
यस सर
Okay. What is ISL? ISL, let me pick up the ISL frame first. ISL header. A lot of details. To be frank, I'm not going to even cover in depth about ISL. No one much talks about it. This is a 26 bytes of header, out of which your VLAN ID is given over here. Okay. And ISL, the way ISL have a header, it also have a trailer, or you say the one which is sitting at the back of it, which is 4 bytes. This is for your CRC checks. Integrity of the frame. CRC is basically that it should not be corrupted or anything else. That is, integrity of the frame is checked via CRC. And combining this two is going to be of 30 bytes. And that's why it is also called as double tagging. What it is called as?
Double tag.
Double tagging. Why? Because one tagging is happening at the front end and another tagging is happening at the back end. Understood? Don't even ask me in depth about it. No one is going to ask you. It is already outdated. And how am I going to configure it? Instead of interface Ethernet 0x2, switch port trunk encapsulation is going to be ISL. That's it. Show interface trunk. Do you see what is the encapsulation mode it is using now? ISL. Now let's try to do something, maybe something interesting. I will bring it back to 802.1q and we have a lot of blocking happenings as expected. And you can't use two different type of trunking protocols on a same link. Okay, it means on one side you are saying that I will configure trunk, on another side on one side you are configuring A2.1q, on one side you are configuring ISL. That is not going to work. It ideally is expected to be same. Why it is not working? I believe yesterday we had shut down that interface. Let me bring it back. Still not working. Why? Show IP interface brief. Show interface. It should be good now. Is my machine down? This is working. Okay, this is also working now. Let's send probably 10 packets. That is a problem. I'll try to ping from switch 1 to switch 2. What is IP? Okay, IP is good. Size 1500. 1500 is also good. Repeat 1000. Everything is working. Okay, I'm trying to ping from switch 1 to switch 2. The basic ping I'm doing. I sent probably 10,000 packets and I got 10,000 packets as a reply. Now what I'm going to try is we will try to make trunk encapsulation mechanism to be ISL. And I will do it on both sides because only on one side it is of no use. So what I have to say, interface thread 0/2, switch port trunk encapsulation ISL. Let's check out. So show interface trunk. Just want to validate something with you guys. Okay. I'm not able to send the data. Earlier I was able to send the data. Show interface trunk. The trunk is working absolutely fine, but I'm not able to send. Do you see I'm not able to send the traffic? Yes or no? Something is broken. Probably ISL is not even supported on this platform. Interface trunk, show interface status. Okay, everything is good. Looks like there is some limitation, not limitation, but you know, this iOS is having a problem that it is not even supporting ISL. I'm not even able to ping to the device. So it means somehow with ISL, this specific iOS what I'm using is having some kind of problem. It is not able to tag the data, or it could be something else. But from a configurations perspective, all you have to do is this one. Switch port trunk encapsulation ISL. That's it. You don't have to do anything else, nothing fancy. It is a plain one-liner. Any kind of doubts with this?
ISL stood for?
ISL stands for inter-switch link, which is a Cisco proprietary. Did you hear me?
Yes, sir.
Sir, what is allowed VLAN, sir? I don't know.
Allowed VLANs. By default, whenever you configure the switch port mode trunk command, do you see the third line command is switch port mode trunk?
Yes, sir.
So what it will do, it will allow all the VLANs Okay, it will allow all the VLANs which are like 1 to 4094. All the VLANs will be allowed by default. Okay. Now let's say you want to only allow some specific VLANs. Maybe VLAN 10, VLAN 20, VLAN 30, and VLAN 40. That is a meaning that I'm only permitting VLAN 10, 20, 40, and 100 here. And rest, none of the other VLANs are permitted.
Sir, when we configure VLAN, so basically VLAN 10, and it is automatically allowed VLAN, sir. Normally configure VLAN, sir. Not in the trunk.
If you don't have this command and this, then yes, everything will be by default allowed in trunk.
Yes, sir.
Understood?
Okay, sir.
And if you have said that I'm only going to allow VLAN 10, 20, 40, 100, 1000, whatever you write, it will only allow those many VLANs, those specific VLANs. It will not allow anything else. What do you see here? I'm only allowing 10, 20, 40, and 100, right?
Yes, sir.
And if you check the same output of trunk, what it says, VLAN allowed on trunk, what it is saying, 10, 20, 40, and 100.
Yes, sir.
Now I will create
Sir,
VLAN.
Sir, it means this switch port trunk allowed will मतलब sir एक टाइम पे सब कोई VLAN साथ में allowed कर सकते हैं मतलब.
Nahi sir, whenever it is switch port trunk allowed VLANs, whatever VLAN numbers you have put, it will only allow that VLANs.
What we have VLAN created.
Even if we have VLAN created, let's say I'm creating VLAN 200, okay? New VLAN.
Yeah, then VLAN allowed on trunk 10, 20, 40, 100, and 200.
If, not now, hold on. Show interface trunk. What my trunk says, which VLANs are allowed?
10, 20, 40, 100.
10, 20, 40, and 100. Am I allowing VLAN 200 here in this command? Am I saying that I am allowing VLAN 200?
No, because we have not created for 200.
I created VLAN 200. Just look at this.
But we have not allowed.
We have not allowed. Until and unless I don't allow the VLANs, it will not be allowed. If you want, so let me show it again. I'm removing all the configurations on 0x2. Okay. And this is a command to remove the configs on one specific interface, default interface, and whatever is the interface name. Okay. What do you see now? What are the VLANs allowed on trunk?
124094.
It means everything.
Yes,
right? 0/2. Now I will say I'm only going to allow switch port trunk allowed VLAN 10, 20, 40, 30, for example. Okay. What do you mean by this? I'm only allowing 10, 20, and 30. Okay. Show interface trunk again. What it is saying, which VLANs are allowed? 10, 20, and 30. Correct? Is it allowing VLAN 100 and 200, which was allowed earlier?
No.
No. Why? Because I am explicitly saying that I am only allowing VLAN 10, 20, and 30.
Yes, sir.
So it means on the trunk port we allowed these VLANs.
Yes, that's what I'm saying, that whatever you explicitly put, explicitly means whatever you specifically write down, only that VLANs are allowed on that port. Clear?
Yes, sir.
Yes, sir.
Okay. Last but not the least topic. Do you see this important here? Native VLAN. Do you know what is native VLAN concept?
I'm not sure. I know it's broadcast, right? But
no.
I know we always shut that down.
No, that is not a case.
Default VLAN?
No. By default, native VLAN is 1. But what do you mean by native VLAN? Hold on. Switch 1, switch 2. Okay. So what is native VLAN? Native VLAN ideally carries the untagged traffic. So whatever is your native VLAN, that will carry the untagged traffic. It is same like access port. Okay, what happens in access port? The traffic is untagged, correct? Yes or no?
Yeah, understand.
Now, with native VLAN, that specific traffic, even if it is traversing or even if it is traveling on the trunk link, any traffic which is part of VLAN 1 will not have any kind of tag. So let's assume this is a machine, okay? PC1, PC2. I have configured this to be part of VLAN 1 here. Okay? Sorry, VLAN 1. And here also this is part of VLAN 1. Clear? Let's say I send some data from PC1 to PC2. Whenever it will land on this device, what do you expect? If this is my trunk link, these are for sure access and this is access. If this is trunk link, whenever traffic traverses or whenever traffic travels between switch 1 and switch 2, it should be tagged. Do you agree on this?
Yes.
Yes.
Yes, sir.
But for native VLAN, if any kind of traffic is sent between switch 1 and switch 2, on native VLAN, it will not have any kind.
Did he freeze?